Comment 1934 talks about average value versus expected value, and I'm basically saying that they're two sides of the same coin. And the practical effect of this is that if you're asked for an average and you've earlier worked out an expected value, save yourself some time, they'll be one and the same thing. Equally, if you've worked out an average and you're asked for the expected value, well, they'll be just one and the same thing. Now, why are they two sides of the same coin? Well, it's because of the link between experimental probability and theoretical probability. If you were planting 10 pots and there was an 80% chance of flowering, then the expected number of pots that you would get is obviously 8. If you're not expecting 8, then why on earth would you say that the probability of getting 8 flowers is 80%? No other number makes sense to be expecting other than the number 8. Of course, it's not a guarantee. You'll get 7, maybe you'll get 9. You won't get obviously any more than 10 because there's only 10 pots. Sometimes you might get 0. But the point is, number 8 is the only thing that you would be expecting to get. Now, by the way, that's separate from the question of whether it's wise to expect 8. If there's loads of other possibilities of what you could get, it might not be a smart thing to expect 8. It might be a really dumb thing to bet on getting 8. But the point is that if you're going to expect something, that's the only thing that it makes sense to get. Now, what's the link between that and average figure? Well, if you ran this experiment of planting 10 pots every season for the next 1,000 years, what I'm saying is that sometimes you'll get 9, sometimes you get 8, sometimes you get 7. You might get 7 3 times in a row. You might get 0 on a freak year. You might get 1. You might get 5. Now, what I'm saying is, if you do an experiment in which you write down the number of flowers you get for all 1,000 years, you can obviously work out the average of all those figures, just like a year 7 would. You add all the figures up and you divide by 1,000, and what I'm saying is that the only thing that makes sense is for that average figure to be 8. Because otherwise, why would you say the probability of getting 80%, getting the flowering was 80%? Now, in any particular experiment of doing this 1,000 times, it probably won't have an average of 8. Maybe it'd come out an average of 8.1 or an average of 7.999 because you had a fair few 8s, but just the right number of numbers other than 8 to cause the average figure to be other than 8. But what I'm saying is, if something really does have an 80% chance of happening, then theoretically, if you did that experiment 1,000 times in a row, you get a whole bunch of figures that were maybe not exactly 8, maybe were different from 8, but they would average out to be 8. I've also said that that means that the only figure you can really expect if you're betting on something is for that 8 figure, because why on earth would you be saying that the probability of the thing flowering was 80% unless you're expecting 8? If you're expecting 9, you would have said that it was a probability of 90%. If you're expecting 7, you would have said it was a probability of 7%. Even if you're expecting 7.8, you would have said the probability was 78%. So what I'm saying with comment 1934 is that there is an intimate link between what you expect and what you would get on average if you ran the same experiment over and over again every day until the end of time.